Yeah, good morning. How is everybody doing today? Good to know. So today I want to talk to you about Android Work Manager. So this is something that Google announced like a year ago, and it has been in alpha since quite a while now. And recently it was like hit the stable channels. We'll look at what the problems were, like what can you use it for, what use cases does it solve specifically, and so as a this I work at a company called as Redmart. We do online grocery delivery in Singapore. So one of the challenges was we support offline modes for our apps, wherein the drivers, the consumers can place orders without the internet, and then all the information would eventually sync back to the server. So we were very interested when Work Manager was announced. We have been using it in production since it was in Alpha 2, and we recently migrated to stable channel as well. But one of the reasons and motivations today that I wanted to speak about this topic is to ensure that, like, it is, while I love the library and it does everything that it promises to very well, there are a few things that are not pretty straightforward, and I would have liked somebody to have helped me. The documentation is still not that great as I would expect it to be. So one of the reasons that I'm trying to do this is so that you don't shoot yourself in the foot with it. So background processing in Android has been around for quite a while. Like, everybody knows what background processing is. You might want to be running the service to do some data sync, you might be uploading logs, all of those things, right? So not something that is new. And you have variety of options on Android to do that. So you have threads and executors. You could of course spin off, write your own threads, use executors, and go ahead and do your background work. You could use services provided by Android as well to do that. You could use the alarm manager as well, wherein you could fire off a broadcast intent, broadcast, and all of those things. You could use async tasks, while they are still very limited to what they can do, but yeah, it is still one form of background processing. And you could eventually even use download manager if you have long running download operations which you want to keep running in your app. While all of these work, and these have been various solutions which we have had for quite a while now, there are a few restrictions that kind of hamper this as well. So those mode came in to picture, which started cutting down a few things on battery, and when your app would have access to the radio and all of those things. We then came up with background service limitations as well, like how long can your background service run, and based on the use case, Google started putting locks around it as well. App standby buckets is something which has come out recently as well, wherein based on how frequently the user is using your app, that is how Google would decide how much of background processing can the app do. Plus, the user can of course now go ahead and manually disable background processing for your app altogether as well if you seem to be consuming more battery. So with that said, Work Manager came into picture, wherein as an alternative to background processing, it is not a complete one-stop solution for all background work. Please keep in mind, Work Manager is very specific to what it does. It is not for anything to do with UI. If you have something which you want to update the UI, do an operation, update the UI, then Work Manager would not make sense. Work Manager only makes sense if you have something which needs eventual guaranteed or eventual consistency. Like, that data is very critical to you, irrespective of whether the phone has enough battery, the phone has network. Like, you do not want to lose out on that data, but even you are okay with it getting whenever it can get to you. It's not time critical or time bound. So Work Manager generally solves all of these cases. Let's look at what it has to offer in terms of this. It supports API level 14 and above, so that is one good thing, that you don't need to bother with broadcast receivers, alarm managers, job scheduler for that matter, all of those things are taken care of, and if you support API level 14, you can still use this. Then it supports constraints in the sense it lets you define, okay, I need to have the user at least needs to have like so much of battery, it should be charging, it should have so much of connected to the Wi-Fi network, all of those constraints as well. It can do multiple chain tasks together as well. This is something which is I'm very excited about. So if you have a sequence of operations that need to happen one after another in a sequential order, but due to lack of internet, then it becomes very tricky if internet comes back and the second task executes first rather than the first actual task which you had scheduled. That was like, you could do it, of course. You could maintain your own job queue. So there were a lot of libraries which used to handle this problem for you as well, wherein they would allow you to have a job queue and add jobs and they would execute in that order. But yeah, you would still what Work Manager does excellently well is excels at chain task, wherein you can say, okay, after this task is complete, only then execute this task. So we'll look at it and in detail as well going forward. One of the biggest thing is guaranteed work execution. What this means is your app can support a full complete offline mode without having to worry. All the data changes that you would save would eventually be synced back to the server. So a sample is worth 1,000 explanations. So I came up with that today morning. So let's quickly go through an example as to very basic how would you get started with a work manager. You would add the dependency, then you would extend the worker class, then you would override a do work method, you would return a result, and eventually you would schedule that work. I know this is quite a lot, we'll look at them one by one. So this is how the dependencies look like: Java, Kotlin, testing, all of those things exist. This 2.0.0 is the Android X version, 1.0.0 is the regular Android version dependencies. This is the stable version. Side note, for everybody who got the Friends reference in the title, a lot of people on the internet have a lot of free time. Today I found there is a site which helps you generate Friend episode names on the fly based on a set of inputs. So the next step basically after you add the dependencies is you would go ahead, extend the worker class. After that you would override a function called as do work, which is returning a result. Some work is something, what work you want to get done. We'll look at more details. And eventually you would say return result.success. And now you have done your work, scheduled, done everything, told how to execute it, what to do, and return whether it is success or failure. We'll look at the result class as well. Now all you have to do is hand it off to the system to tell it, okay, go ahead and schedule this to be run whenever the constraints are met. So the way you do it is you create a work request using the builder, passing in the worker class which we just created, in which you override the do work method, and then you would say work manager.instance.enqueue the work request which we created. Work request is something, again, a different class. Think of it as a request to the OS to schedule a particular job. Every time you have to create a work request so that it can be scheduled. We'll look at that in detail as well. So before we go ahead, right, worker class, by the class which we extended, right, by itself is an abstract class which extends a class named as listenable worker. This worker class has a function called as do work. This is an abstract method as expected, which we basically go ahead after extending it and overriding the same method. This class also has something called as a start work method. This is the entry point for this particular worker. Whenever this worker is triggered, this method is called, and that internally calls do work like this. So there is the start work method which we spoke about. It fetches a background executor and then calls do work. Basically, whatever your had overridden the do work functionality is got called. This is important because this particular step of get background executor ensures that all of your work happens in the background thread and you don't need to handle threading of any type for your own purposes. So it will always ensure everything that you write in the override and do work method is always run on a background thread. The result class which we spoke of is internally just an enum class. It has 3 different values: success, failure and retry. Success, basically when you say return result.success, what you're telling the OS is this worker has done everything that he had to. You can go ahead and terminate this worker altogether. You don't need to run it again. Then you have basically failure. Basically for some reason, if you are trying to make a network call and you, irrespective of number of retries you fail, you would want to come back and tell the OS that okay, this job has failed and will not be executed further at all. So that is basically, it will be marked as failed and will never be retried ever again. You could also do a third one, which is the retry. The retry is, as the name says, you could say, so you tried to send something to your server, the server returned a 500 internal server error. So what you could do is return result.retry. That would mean, okay, right now I was not able to execute my work. Please go ahead and retry this at a later point of time so that you can keep doing. And you don't need to bother about when and how will it be retried. The work manager will take care of all of that for you. So all you need to do is, yeah, this has not completed the job it was supposed to do, and we think it is not in a failure state yet, so you should go ahead and retry as well. The one thing, the retry, specific to retry is you can set backoff policies. The default one is an exponential backoff policy, which basically lets you retries after with the exponential backoff. You could of course change this to be a linear one. That is also possible. There is one thing that is missing is it does not give you a max retry count to be set on this. So you can't tell the work manager try this particular job for like 10 times and then fail. So there is no way to do that right now. One of the major reasons for that is if after trying 10 times and you asked it to do, how would the work manager decide what state should it terminate in? Should it be a result.failure, result.success, or all of those states? So to avoid that, what work manager provides you is something called as get run attempt count. This function is accessible in the do work method. So you could call get run attempt count. What this would do is give you the retry attempt number which it is trying to do, and then you could have logic of your own as to what to do if it is more than 10 times. So it would be a simple if check. If get is greater than this, then return result.failure if you don't want to retry it more than 10 times. Then you have, as I mentioned, we spoke about the work request class. This is basically, think of this class as a request to the work manager to enqueue everything that you have defined it to be done. There are 2 types of it: one-time work request and a periodic work request. As the name suggests, both of them do exactly that. One-time work request is basically you have a one-off work. This will not repeat over and over again. But periodic is, okay, I have this work, but it needs to be repeated after certain intervals time, after and after again. So the one-time work request is very simple. You say one-time work request dot builder, pass it the worker which you want to execute whenever this is met, constraints are met, dot build. The periodic work request is very similar. Periodic work request dot builder, the worker, it takes in interval and the time unit as well after how long you want to try this. One thing to notice here is, though this is periodic work request, there are 2 things that will happen in this case. Since it is a periodic work request, this worker will never reach a state of completed or success, and it will always go from enqueued running and back to enqueued, since it is periodic. So if you have logic around the fact that this will return a success and then you would want to do something, then that would not work. This is one of the reasons why periodic work can't be chained in work manager as well, because that would not make sense, because it would never come and reach a terminal state of completed or successful. So that would never, the next chain work would never get executed. Also, something which is very unique to this periodic work request is the minimum time which you can set for the repeat interval is 15 minutes. Anything less than that will be ignored and will default to 15 minutes. So if you are trying to use periodic work requests for intervals wherein you want data to be synced at lesser than 15 minutes, and that is not what you should be using. Work Manager can't help you in that case. The whole idea of Work Manager was to optimize battery and performance based on the best conditions possible on the API level of the user. So this is something you might want to keep in mind before deciding if you want to use Work Manager, because less than 15 minutes won't be possible. Then that is the minimum, plus 15 minutes plus if your constraints which you have set are met, or is the second condition. If you have no constraints set on it, then yes, in 15 minutes it will retry the work. So there is something called as tags which the Work Manager provides as well. The tags, think of tags as basically human readable attachments to each work. So like every time you enqueue or tell Work Manager that this one piece of work is what I want to be enqueued, it comes back to you and gives you a work request ID. That is nothing but a UUID which is being used. You can use that ID to query the work, and all of that, we'll see all of that later. But the tags are very important. Basically, it helps you logically group your work together, and you could basically then query them by that tag and then later cancel them as well. So you could also have multiple tags as well on single work request. You could have multiple tags as well. This is what it should look like. So when you create the work request, you could do something called as add tag and give it a name, whatever you want to. This is both doing the same, sync and driver activity and sync and job status. I generally try to do this because it gives me much finer grained control on this work request. So what this lets me do is, let's say at a later point I want to cancel all my sync jobs. I will query all the jobs with the tag sync and cancel them. If I want to cancel only job status related jobs, I will query by the tag of job status and cancel only the first one, and the second one would still execute. So this gives you fine-grained control. Like, of course, all of these are sync jobs, but you could either want to cancel all the sync jobs, or you would want to cancel a subset of them. So you can ideally group them logically, so that you can call query that based on that tag and then cancel them accordingly. So we looked at constraints as well. So it provides multiple types of constraints which you can enforce. One is the network constraint. Basically, should it be connected to the internet or should it not be connected to the internet for your job to execute? It looks at battery as well. Should the battery be above a certain percentage to execute this particular piece of work? It looks at storage as well. Does your work try to write a file to the database and you would at least need some space to write? So that way you could set the storage as a constraint. So even though your write operation fails at that point of time because the constraint would not have met if he's running low on storage, later when the user has freed up space on his device, this work will automatically get executed. So you don't need to worry about that work not happening due to low storage. So you could tell the work manager, okay, if there is low storage, please do not execute this, and only do this once you have the most available. You could also tell work manager to set constraints around device state, whether it is idle, whether it should be in charging. All of those things is also what you can control. So you can tell that the device has to be in the idle state and not doing anything for my work request to execute. So this is what it looks like. There is a constraints class and you have a builder on it. You say set network required network type. I say it should be connected to the internet. Set requires battery not low to true. If what this tells the work manager is, if you go ahead and the battery is low, then your job will not be executed at that point of time, but at a later point wherein his battery is much higher. Set requires charging is basically is the device necessary to be connected to a charger while this job needs to be executed. So that is one thing you can set as true or false. Set requires device idle as well. Again, as I said, whether you want the device to be totally idle before your job is being run. is something which you can control. Set requires storage not low. This is again what I mentioned is how much do you require the storage as a functionality, as a constraint. Like, if he's running low on storage on his device, then your work will not be executed. By default, these are everything set to false. You can of course modify them as per your will and wish. If you do not set a constraint on your worker, none of the constraints will be applied, so it will execute it as if none of these ever existed. So if you are trying to do a API call within your do work, and at that point of time, if you do not set required network type to have internet connected, it will still run it when there is no internet. So based on that, you want to build your constraints accordingly. I generally try to group them like this, wherein I have a private function which says get worker constraints, which based on a certain set of conditions returns the constraints for multiple workers. So the way we have set it up in our system is we have a helper class which coordinates all work manager related things. So there is this function which gets workers constraints based on the worker as well. So I told you that the chaining is something which Work Manager does very well. Let's look at what I mean by that. So what you could do is you could say Work Manager.get instance. So let's assume you have work 1, work 2 and work 3, 3 different work requests which you have created. Now what you want to do is start with work 1, and only after work 1 has completed successfully, you would want to do work 2 and work 3. So, and since you do then and then work 2 and then work 3, this would ensure it always happens in a sequential order. Work 1 will be executed first, work 2 second, and work 3 last. And this can be very helpful if you have Work Manager do things which need to execute in a sequential order. What's the power of it is, the work 1 and work 2 can have different set of constraints altogether. Like work 1 could be an API call, work 2 could be writing to a database, and those will execute when those constraints are met. So you don't have to worry about it, okay, work 1 is different work, but you just have to tell it, okay, this is the order I want it to execute in, and based on the constraints which you provide for each work request, it will automatically figure that out for you. So then work 1, then work 2, and then NQ. There is also a way wherein you could tell, okay, I want all the 3 works to run parallel. Like these are not dependent on each other, and I would want all the 3 of them to work parallel. One caveat with this is you could do NQ, and this is a var constructor. You can pass as many work requests you want. One caveat though is, though this runs them parallelly, it does not mean it will actually run them parallelly. It is based on availability, resources, threading, and all of those things. You just say that when you say this to the Work Manager, all it looks at is, it does not need to bother about work 1 completing before it can start work 2. So in a real life scenario, what would happen is work 2 can get completed first and work 1 later. So in this case, the sequence will not make a difference at all. So let's try to combine both of them. So you could say work manager.getInstance.begin with, and say work 1, work 2 and work 3 can run whenever they are. And then you want to do work 4, work 5 and work 7. So what this basically did was, the Work Manager could choose to run work 1, work 2, work 3 as and when it felt it was okay and the constraints met. What the power this does is, work 4 will never start before all the 3 of them have completed. So irrespective of when they get completed, work 1, work 2 and work 3, it does not make a difference. Work 4 will never start before all the 3 of them have been completed. So this brings in that powerfulness wherein you can combine multiple parallel tasks and sequential order both in a single workflow as well. So also you need to understand, work 1, work 2 and work 3 could also have different constraints of their own, like network versus this and this. They will be run at different times accordingly. Though they are supposed to run parallelly, but it can run whenever the constraints are met. So let's look at a simple example, right? You have work A, and then once work A is completed, you want to start work B and work C simultaneously, because both of them are not dependent on each other. But only after work B has completed is when you want to start work D and E. So B, C, D and E. This is what it would look like. You would say work manager.begin with A, because A is the only task which you want to run first. And this comes back and gives you something called as a work continuation. This is a helper class which lets you chain work together. So this is every time that you enqueue, before enqueuing a work, this is what the continuation object comes back to you. So you could keep adding more and more chains of work to this object as we do here. So we start with A, then I enqueue C. Look at it very carefully because C had nothing else to do, I then enqueue it right away. But when I do B, I say, okay, after B is completed, I want to execute D, then D and D. So this would ensure what would happen is A would execute first, and then C would execute and B would execute simultaneously because both of them are not dependent. But D and D would only execute after B has completed successfully. While we are talking about nesting and parent-child relationships, one thing also to keep in mind is if along the entire hierarchy of chains of work which you have created nested, if one of them fails, then everything else in the child will automatically fail. So if one of them returns a result of failure, the entire chain of work would return as a result of failure. So if you are trying to use this for a scenario wherein you are like, okay, try doing this and finally do this, that would not work because if one of them fails, the last task will never get executed. So you might want to keep it in mind that when you are trying to do this, once a parent fails, everything below that will automatically be set to fail. It would not even try to run the operations. So another example, right? So you start with A, but this time I want to, once A is completed, I want to run B and C simultaneously. I don't care, they are not dependent on each other. But only after both of them have completed is when I want to start D and D. Like I don't want to start D or E before both of them have completed. So this is what it would look like. Simple again, begin with and then give the continuation. Then you would say then B comma C, and you would then say after B and C has completed successfully, only then go ahead and do D comma E. Last example, you could have multiple chains of work being chained together as well. So assume this wherein A needs to start and after A is done, B will be executed. And in the other case, C needs to start and only after C is done, D will be executed. But now when this chain 1 is done and chain 2 is done, only then I want to execute E. So this is also possible. So you start off with that, get instance, begin with A, then you say B, and what I also do is begin with C and then I say D as well. So basically that created that hierarchy wherein it would execute D only after C and A only after B. And since both of these things do, chain 1 and chain 2 don't depend on each other, I could go ahead and say combine chain 1 comma chain 2. What this would do is take chain 1 A to B relationship and take chain 2 C to D relationship and then run them parallelly as well. So that is very powerful. And then finally what I would do is after both of those chains have completed execution, go ahead and run work E, the finally is this. So while we have been saying you could enqueue work, have multiple chain work set and everything, right? It is very easy that you would want to start scheduling work in your application class, in your starting launcher activities. That can be very tricky because let's say you want to do a sync operation, everything that has been pending since the last sync happened, and you start this in your application class, like as an example. What will happen is every time your app starts up, that worker would get created, and let's assume you chose internet to be a constraint, that it has to be connected to the internet to work. So let's say out of the 5 times he opened the app, 4 times there was no internet, and the 5th time he got internet. What would happen is the work manager would now throw 5 different work requests and all the 5 of them will execute, doing the exact same thing over and over again. So, but that is not the behavior you would want, right? Like sync job, you do not care how many times you want to sync. As long as it syncs once, that is all you care about. So you have something called as unique work. So basically, what unique work does is it lets you tag something, piece of work, and say, okay, if this is running already or is scheduled to run in the future, then behave differently. We'll look at why I said behave differently. So in this example, I say my unique name, enqueue unique work, the method construct is different everywhere. The enqueue unique work comes into picture. You pass it the name which you want, the unique work name. Existing work policy dot replace. So this is basically where it comes into picture, which defines what would happen to the existing jobs if a new job is scheduled with the same unique tag. And of course the work request which you want to execute. Existing work policy has three different values again internally: replace, keep, and append. Replace cancels everything that is existing previously. So out of the 5 times, 4 times there was no internet, there are 4 connections. But if you had tagged it as unique work, what would happen is the second time itself the first one would get cancelled. If you had said replace, only the newer one which you are scheduling will take preference. Everything older will be replaced. The keep is basically keep the older ones and do not schedule the newer ones. So if there is already an existing task for this which is pending, then keep that and forget that I added this new work request. Append is okay, you have already a few things which you are doing, but I want this to be appended to that as well. So based on that, this policy defines what kind of a behavior it would execute in your case. So work manager also lets you query the status of a particular work. So you can know what state the particular work is in right now and what to do with it if you want to. So again, you could query by ID, by tag, and by unique name, all these 3 things which we have seen. I would generally prefer to avoid the ID because the ID is given to you when you enqueue it. So it is, unless you persist it in your database across app restarts and system reboots, you would not have access to the work ID. So that can be very tricky to work around with if it has to be, if you want to query something which was in an app session before and not the current app session. So generally tags are the way to go, wherein you could tag every piece of work which you are doing and then you could always query it back based on that tag. So you don't need the work ID for that to this. If you have unique work, of course you can go ahead and use the unique name which we provided to query them back as well. So let's look at all the 3 of the, you have both the live ID version and the regular version as well. The live ID version gives you the live data version, whereas info by ID will give you a listenable feature which you want. Based on what you are using, this is both possible. By tag is what we looked at, so you just pass in the same thing. One thing quickly here to notice is this will always return a single, when you are querying by an ID, it will always return a single work because the ID is unique for each work. So this will always return a single piece of work, whereas info by tag will return you a list of work because everything that matches those tags will be returned back to you. So this is where I was mentioning that you could now do fine-grained control based on the tags. You could query whichever tags you want to. And by unique name, again, it returns you a list of work requests which have been tagged with that particular name. So you could go ahead and cancel work as well, whichever you have already scheduled. Again, all the 3 options exist. You could, if you have the request ID, then yes, you could pass in the request ID and cancel that particular work. You could cancel work by tag. This is what you could do is, based on what operation you are trying to achieve, you could choose what tag and all the work related to that tag will get deleted. So it makes sense to name your tags very logically and group them for a particular operation. So generally what I tend to do is have 2 tags. One is at a global level, what it defines what it does. So sync is one thing, right? I am trying to sync data in this particular work request. But I also do a fine-grained control saying, okay, this is upload, this is download. So you could only download, you could only cancel all the upload tasks or just the download task if you want to. Or you could go ahead and say, okay, everything related to sync, just get rid of it altogether. Again, you could cancel unique work as well. There is one function which is called as cancel all work. I would never call this function because it can break a lot of things for you, because what would happen is, let's assume you have a third-party library who also uses Work Manager to do their set of works. cancel all work would cancel their work as well. So that would be a very tricky thing to do. So tags, as a tag, if you are a SDK developer or a third-party library, what you would want to do is tag your works with your unique name, so that even if he cancels everything else, your work does not get cancelled. And as a consumer, never try to call cancel all work unless you have a very solid reason. We have one use case, we'll look at that in the future, where cancel all work will come into picture. So that is pretty much in terms of what Work Manager can do, what we can have with it, what are the problems with it. But over the past 1 year, we have been using it. There have been a lot of cases wherein we thought of it like, that happened, and then we realized, oh, this is not how it works. So what I would like to do is touch upon a few points. Generally, scope your works to use tags to limit your scopes of work, so that you do not cancel, end up in a situation wherein you have hundreds of jobs and you don't know how to cancel each of them. So it is always easier to group operations together. Multiple chain jobs will execute at different times. This is something which we didn't think of so nicely when we first went ahead with it. So if you have two works and both of them have different constraints, even though they follow a hierarchical pattern, they could execute days apart as well. So that can be very tricky, that one piece of information is already synced on your server and the second piece has never arrived. So we were very surprised to look at those logs in the backend wherein there was part A but part B has never come, and 3 days later part B comes to us. So yeah, it can be very tricky, so that you need to understand your constraints will be given priority, and that is how the work will be scheduled. Evaluate trigger points for all your workers. So as I said, if you start all your workers in an application class or a global class or a launcher activity, what is going to happen is, if they are not unique, you will start piling them up one after another, and they will execute parallelly once all the constraints are met, with the exact same data having to be sent. So you would want to really evaluate when would you want to use start your work requests, and do it in a way wherein you understand that it would not be called multiple times in case your constraints are not met. So every time you are trying to schedule some work, think about what constraints you have given, and think about the case wherein can this be invoked multiple times if the constraints are not met. You do not want to be in that situation. One-time work request and periodic work request share tags. So what's funny about this is, so let's say you have a one-time request and a separate periodic request, but you gave both of them the same tags, that will still work. But it is not that the periodic work request will have a different set of tags and the one-time work request will have a different set of tags. This can get very tricky, especially if you try to start one-time work request with the same tag, but after a periodic work. So you schedule a periodic work, give it a tag. Now you go ahead and schedule a one-time work with the same tag. Your one-time work request will never execute, because periodic work by nature would never reach a success state. So that the next day, assuming that you do a append on the work policy, if you say, okay, existing work policy dot append, that would happen wherein your one-time work request will never execute. So you would want to look out for that. There is a function called as is stopped. So in your do work method, let's assume you have something which does a for loop. Like you want to sync multiple data and do it every time individually. Within the for loop, you have all your logic written. What can happen is, while that for loop is executing, the network constraints might change. Like if you had said internet is necessary for my work to happen, and once the constraints met, the first job executed, but when it came to the second job, there was no internet. So what would happen is, since it is in a for loop, it will keep trying to do that and keep failing. But the whole point of it is, you should not even be trying to do that. There is this function called as is stop, which tells you, is this worker currently stopped? So that, okay, if somebody has cancelled it or the constraints have gone away, this method will tell you whether this current is active or not. So you would add a simple if check in your for loops generally, whether before doing any work. If it is stopped, then you would not want to do anything, because in that case, even if you return a result or success, the work manager will ignore that result because the worker is no longer active according to the work manager. Cancel all work before removing work manager. So this has been the most popular complaint that I've heard from people. People jumped on it in alpha versions and then realized, okay, this is not stable enough for us, our use case yet, let's remove it. People went ahead, removed the library, all the code and everything, and they started seeing crashes. Because the work manager schedules future work. You could have work which was scheduled 2 days after, but now you have a build out there which does not even have the worker class to work. So it can be a very tricky position to be in. If you are removing work manager for whatever reason, try to do it in a way of two-step process, two builds, wherein in the first build where you would cancel all existing work and not schedule any new work, and then after that get rid of work manager. So this is a little tricky as of now. There is no solution around it. It has been something which is a lot of people have been facing, especially wherein you have future work which is pending and that would try to execute. So just to quickly summarize what we looked at, right? It runs on a background thread. This behavior can be altered if you want to provide your own executor or use core routines for that matter. You could, instead of extending the worker class, there are classes which do the specific mapping as well. So you could use your own hand-rolled executor as well. Then you have it execute, of course, ensures execution across system reboots because of the nature of work manager. We'll quickly get to that as well. It also is very nice in the sense it based on what API level the user is on, it would choose the appropriate method. If he is on API level 14, then work manager will use alarm manager and the broadcast receiver to schedule that work. If he is on API level 23, it will use and above, it will use job scheduler automatically. It takes care of wave lock handling for you, so you do not have to worry about when to hold the wave lock, release the wave lock and wake up the radio and all of those things. It automatically does that for you. There is nothing related to wave lock for you to work. Internally, just to give you an idea, this will make things much clearer. It is using a room database to save everything every work request you schedule gets saved in a work room database internally. Hence, this is the reason why you can query it by ID, tag and all of those things because it is a database. It also means, as I said, if you remove work manager, that database still exists in your app and that feature work will still execute. That keeps snapshots of work being done, hence it is queryable, so it knows what status each work is in, and even after the system restart, it can automatically fetch all of that data and re-query the work. It can restart pending work. This is one thing that got us off guard to begin with is, of course it runs it on a background thread, but it would run it synchronously. So if you are trying to extend the worker class and do RX Java with a different thread and all of those things, that would not work. You also have a different RX Java worker which will ensure that to happen. So we were very stuck with this, wherein in the do work function we basically had multiple tasks which were trying to take care of spin off multiple threads and do things parallel. That would not work because the executor, which underlying default executor provided, has one thread as the allocated thread. So everything will run in a sequential manner, and that is why in all of our examples which we saw, do work, I would say do this work and return result.success. That is one of the reasons why result.success would not be, if even though this is happening in a background thread, it would not just return immediately and go back because it is a single threaded executor. It would wait for the work, and this is how the synchronous behavior comes into picture as well. So yeah, that is it. You can reach out to me at Twitter. You could also come up to me and talk about Work Manager, Droid India this year if you want interested in that, or anything Android in general. You can always find me around. Well, anything in Android, but except those two things. And this is probably the most important piece of thing. If you are one of those people who have seen Avengers or read about it already, do not talk to me. Thank you.